Hello, class. Uh, Today I'll be presenting the article I read, which is called Astronomers Confirm There's a Third Type of Supernova Explosion. The article was written by Alison Klesman. It was published Monday, June 28th, 2021, in the website called Astronomy News. Basically, the article talks about what an electron captured supernova is, which is quote unquote the third classification of a supernova. So, background information. So, we currently know that there are two types of supernova. Type 1 supernova is when the remnants of a sun like star, which is a white dwarf, siphons material from a nearby celestial object. Matter surrounds the white dwarf surface, and once it is over the Chandrasekhar limit, which is 1.4 solar masses for a white dwarf, it will explode into a supernova. Type 2 supernova, also known as a core collapse supernova, is a blast that happens when a star is about 10 times the mass of our sun. This type of supernova leaves behind a neutron star or a black hole. So the third classification, known as the electron capture supernova, so calculations date back to 1980, which first suggested this classification. So basically, this type occurs only to stars between 8 to 10 solar masses, which are in a fine line between evolving into a white dwarf or explosively becoming a neutron star or black hole when they die. Before a star's death, magnesium and neon atoms pile up in the core, begin to capture the electrons around them, creating outward pressure which keeps the core stable. Once the electrons are absorbed, the pressure is reduced and the star's inner region begins to collapse into a neutron star, while the outer region blasts outward like a supernova. So in March 2018, Japanese astronomer Kyoichi Itagaki spotted a new supernova known as SN 2018 ZD in the galaxy NGC 2146. The galaxy lies roughly 30 to 40 million light years in the constellation Camelopardalis. After analyzing the blast in a paper published June 28 in the website known as Nature Astronomy, indicated that it perfectly fits the profile of an electron capture supernova. So, astronomers were able to compare images from the Hubble and Spicer space telescopes before and after the explosion. So, this was something new. This time, astronomers were able to compare the star and the light from its supernova to the description of an electron capture supernova. The observations matched the six expected criteria. So the six criteria are that this type of star was a red giant or aging star, called a super asymptotic giant branch star. So these stars are between 8 to 10 solar masses and are believed to be the progenitors of electron capture supernova. Second, the progenitor has shed much of its mass prior to exploding. Third, the progenitor showed unique chemical compositions like abundant helium, carbon, and nitrogen, but little oxygen. Fourth, the explosion was weaker than the expected core collapse supernova. Fifth, the explosion's light behaved how astronomers expected it would for an electron capture supernova. Basically, the light lingered for from more than 100 days as the shock wave hit the outer layers the star previously blew off. And finally, the material left behind was the presence of stable nickel but not radioactive. So the Crab Nebula. So astronomers long suspected that the supernova of AD 1054, which created the Crab Nebula and its central pulsar, was an electron capture supernova. However, the lack of records at the time, which were no telescopes, spectrometers, etc., could not help observers analyze the explosion. The crab does fit some criteria. The neutron star left behind, the chemical composition, and ancient records of the light lingering. Thanks to Itagaki's discovery, strongest evidence linking these two to an electron capture supernova was uncovered? So here are the following quiz questions. The first one is, who discovered the first electron capture supernova? A. Albert Einstein, B. Alison Gletzman, or C. Kyoji Itagaki? Number two, what two instruments were used to analyze the SN 2018 ZD? A. The James Webb Telescope and Kepler Telescope, B. The Hubble Telescope and Spicer's Telescope, or C. The Sputnik 1 Telescope and Voyager 1 Telescope? Finally, the last question is, which is not a criteria of an electron capture supernova? A. It is a red giant or part of the AGB branch. B. It has a unique chemical composition. Or C. It leaves radioactive nickel behind. So this is all for me, and thank you for listening.